Right, so in question 5, what we've got here is, again, we have a normal curve. We're told what the mean is and the standard deviation. So let's just draw this guy up. Mean is 45. And what we're told is that somewhere around here, there's a point on this graph at K such that the area to the left of that K between the curve and the x-axis is equal to 0.25. And from that information, we have to figure out what that K is. So that's actually, it's a pretty difficult thing to do if you didn't have a calculator, but fortunately we do have a calculator. And the way to figure out what that K is to use it. So let's exit back out of here and go into dist and norm again. Now we're back to these three options. The option that we want is this inv n1, which stands for inverse normal. So if we go into here, there are 3 inputs into this, but actually on your calculator you'll probably see 4. The first thing on your calculator, it'll probably say left up there. What that's talking about is the tail, so it'll say something like tail left. These things here, where the parts of the normal curve where it starts trundling off away to really small values, these things are called tails. And there's a left tail and there's a right tail. Now here we're dealing with the left tail, so our area is underneath the left tail. So your calculator, when you're doing this, should be set to tail left. Now my calculator always assumes that I'm dealing with areas to the left, so I don't have that. But anyway, the first thing I need to give my calculator, and the second thing that you'll need to give your calculator, is just this 0.25. And then we just need to tell it what the standard deviation was. It was 8, and what the mean was, which was 45. And then it tells us that K is going to be equal to 39.6. So this point here is actually 39.6 if you figure it out. So let's just write that down. I'm going to say that K is equal to this inverse normal function. Now let's go back and have a look at what it was that we put into the calculator. The first thing that you've probably put in, if you have a more modern Casio calculator, is you've told it that the tail is the left one. The next thing we tell it is the area, and then we also need to tell it the standard deviation and the mean. And that, when we calculate it, was 39.6. Now we can always check that answer. Now this is optional, but I'm just going to do it just to make sure I'm correct. I'm going to say check. And let's actually calculate the probability that x is less than or equal to 39.6. So pretty much I just replace this k by 39.6 because that's what we know it is now. But if I take this and I actually calculate this, well, it should give me 0.25 back. So I'm going to say that this is equal to NCD. Now the first thing for NCD was the lower, so it's going to be like minus 1,000. I want to go up to 39.6. I have a standard deviation of 8 and a mean of 45. So let's just drop that into the calculator. So lower is, we've taken minus 1,000. Next one is 39.6, 8, and 45. So we end up with 0.24. Well, it's close to 0.25 as makes no odds. So I would say that our calculation of K was correct. Now for the next part here, it's very much the same, except now we have a piece of area which is to the right of some k. So there's our mean. And it's going to look something a little bit like this. And then over here somewhere, we have ourselves a k. And we're told that wherever that k is, it must be in just the right place so that this area here, all the way up to like infinity, is equal to 0.3. So once again, let's use the inverse normal function. Now unfortunately for mine, on my calculator, I can't actually get that directly. So what I'm going to have to do, because my calculator always assumes that I'm looking at an area going out to minus infinity instead, I have to use something a little bit clever. And that little bit clever is that the area underneath this normal curve is always equal to 1. It's always equal to 1 because the probability of x being anything at all has to be equal to 1. So x being anything at all would just be the area under this curve altogether, so the total area is just equal to 1. So from that, we can sort of figure out that this area here, this area over here, what that's equal to is it's equal to 1 minus the area from here all the way over to negative infinity. And since this is actually what I'm able to put into my calculator, let's just solve this equation for that. Now we're actually told that this probability here is just 0.3, so we're going to have 1 take away 0.3, which is equal to 0.7. And now I can use the inverse normal function on this. So now if I go k, well, that's got to be equal to the inverse normal function. On yours, if you're doing this on your calculator, you can just use left again. And then I need to tell it what the area is. It's 0.7. And the standard deviation is still 8 and the mean is still 45. So let's drop those things into the calculator. So I shall go back to here to dist, go into norm and look at the inverse normal. The area in this case is going to be 0.7 and standard deviation is 8 and the mean is 45. So on yours we'll just use tail left again. So I get that's equal to 49.2. So this point here, this k is going to be 49.2. So let's just check that to make sure that everything is correct. So if I go check, and let's actually calculate what is the area underneath this graph from k up until infinity. So let's write NCD. And then we want to go from 49.2 all the way up to some massive number. Let's go 10,000. And then we'll have 8 and 45. Lower is 49.2. Upper is 10,000. Standard deviation is 8 and the mean is 45. So we get 0.3. So that is correct. So I'm pretty confident then that our calculation of k was correct. So again, this is the actual answer that the question wants. This is just a check that I did just to make sure that everything was right.